manage to create large language models trained on massive repositories of human knowledge, but out of the box, they are completely trapped. An LLM cannot execute a file, update a database, or send an email. It's a brain inside a jar. To move past simple conversation, we need a feedback loop. This is the process where an AI takes a specific action, observes the result from its environment, and then adapts its next move based on that new data. Closing that loop requires external tools. These act as the digital bridge between the model's text generation and actual execution in the real world. This is the dividing line between a chatbot and an agent. Without tools, intelligence is just a collection of facts. Tools are the upgrade that turns an AI into an autonomous digital worker. However, scaling these agents introduces a persistent friction, the engineering nightmare of custom tool integrations. This is the N times M problem. If you have 3 different language models and you want to connect them to 4 different tools, you have to write 12 separate, brittle connectors. In his book, 30 Agents Every AI Engineer Must Build, author Imran Ahmad notes that this integration bottleneck is the inevitable wall every agent project hits as it grows. The industry cannot realistically scale if developers spend all their time maintaining custom API wrappers for every software update or new model release. The solution isn't to write more integration code. It's to create a universal standard, a USB-C cable for digital tools. The Model Context Protocol, or MCP, is that universal connector. It replaces bespoke integrations with a single standardized framework. MCP changes the mathematics of development from multiplication to addition. Instead of 12 tangled connections, the centralized MCP server routes the 3 models to the 4 tools using just 7 clean pathways. It starts with the host application.
This is the user interface where the AI's reasoning core, the brain making the decisions, lives. Inside that host is the MCP client. This is a translator that takes the AI's intent and formats it into a standardized JSON RPC message that any server can understand. By enforcing a strict boundary between deciding and doing, MCP allows the reasoning core and tools to be upgraded independently without breaking the system. The messages travel across a transport layer, the physical cable of our USB-C metaphor. This handles data via STDIO for local tools or streamable HTTP for remote ones. Before the AI takes any action, the host and server establish a connection and advertise their specific capabilities to one another. Once the connection is live, the AI queries the server to discover exactly what tools, prompts, or data resources are available to it at that moment. The AI then evaluates the tool. The server provides a strict data schema, so the AI knows exactly what inputs are required before it attempts to execute a command. Finally, the AI invokes the tool, executes the action, and waits for the feedback to continue its mission. By standardizing these 3 steps, discovery, evaluation, and invocation, MCP replaces fragile code with legible, typed contracts. To see this in practice, imagine an agent tasked with finding a Q3 report, uploading it to a company backend, and booking a follow-up review. The agent routes a request through a Google Drive MCP server to retrieve the PDF document. Next, it invokes an FTP server to upload the file to the database. Finally, it queries a calendar server and successfully books the meeting. The breakthrough here is that the host AI completed a cross-platform workflow without needing custom code for Drive, FTP, or calendars. The goal of MCP is to make the tool layer completely boring. It frees developers from writing repetitive API wrappers so they can focus on higher-level AI orchestration. Learn to build these autonomous systems with Imran Ahmad's book, 30 Agents Every AI Engineer Must Build, available now on Amazon and Pact Publishing. For more deep dives into the technical architecture of the future, subscribe to the Neurals.ca channel and visit Neurals.ca. Standardized protocols like MCP are the invisible foundations that will allow autonomous intelligence to scale into our daily lives.